All right. So you all came to SRE at 11 million users. My throat's going, so I apologize. But you're actually going to get SRE at 12 million users. We just crossed another boundary. So my name's Zach McCoy. I've been at Jack Henry for 12 years, including acquisition from Banno. You might know Banno from what Wade did before. Done a lot of hats. I've been an IC, engineering manager, tech lead, reliability engineer. I've done observability. I've kind of been through the gambit, but usually I'm in the Scala open source space. I did a podcast for a while, as well as being one of the type level steering committee maintainers and help kind of steer the open source programs for Scala. So we're going to talk about 4 big sections here. Each of these is really probably an hour-long or 2-hour-long talk, but we have about 10 minutes for each. So we're going to talk about observability first. And then once we can actually talk about that, we can talk about measurement, then taming your complexity, and then your response and analysis to instance. So first, we really need to decide what site reliability actually is. There's an entire joke of what the fuck is SRE. I don't think we're really going to get there on this, honestly. So for us at Jack Henry, it's a mindset. And really, that's running reliable systems in production. And also for us, that's our engineering teams, not infrastructure versus engineering, but the teams writing the code are keeping that code in production up. It's about learning from incidents. It's taking the issues that we're having, whether they're socio-technical or purely technical, and re-looping that back into our process. And then also, it's resilience to socio-technical failures. So whether or not it's a process failure, maybe we didn't ping the right people, we need to fix that too. So first, I'd like to go back to 2011, which is the time of Banno, and kind of where all this code started. So we were one really large Scala backend team. And by really large, I mean about 10 to 15 of us. And we had thousands of users. And our application was pretty simple. We went and wrote web scrapers over all of your favorite FIs, put them in a white label app, and then sold it to someone else. What it looked like for logs, though, for us was we were SSHing into boxes. Some of you might be pretty used to this. Metrics were haphazard. They came whenever someone remembered to do it. And we alerted on percentage of failure per application. There wasn't really an idea of the top level, what the user's seeing. It was all, well, my app, my microservice. And we had custom metrics really all over our system. And while that works for 1 or 2, when you start getting to the scale we're at today, that gets unwieldy. And our incident analysis process was really pray. Hope someone thought it was good enough and hope that they were going to do the full analysis. So if we fast forward to today, which is what you really want to probably hear about, is we have 20+ different teams. We're running in Go, Node, Scala, and we have 700+ services running in Kubernetes. We have 13,000 pods. Our team isn't a small number of 20 engineers anymore, it's hundreds. And we're a REST-based microservice architecture for the most part. We have 1,000+ public endpoints. And the other issue is that we're an open API. So it's not just ourselves consuming ourselves like it used to be. So if you were to go into Honeycomb today, that's what you'd see. It's not nearly as bad as like the ones that I think Spotify showed at one point, but it's getting there. So eventually, we got asked to solve for user X. We had certain users that had certain issues, and they couldn't figure out what was going on. The problem is that we can't solve for them. Everything was a dashboard. So we don't have high cardinality data inside of our dashboards to be able to look at a specific user. And our users' issues are going to be subsets. They're not, this institution or this specific group. It was, oh, well, people with 13 accounts that are running in this region. So metrics are too coarse. They're aggregates. You're not going to be able to dive down from just looking at, hey, this group, we can't dive down into which exact people. So with mysterious slowness and failures, our metrics don't have the right hard cardinality fields. You've all been here. Maybe you add your user IDs to it. You now broke something. Someone tried doing something good, and Prometheus doesn't take that. So what's really the answer? And first, we probably need to talk about signals. So OpenTelemetry calls these signals. You might see them as pillars if you want to look at it that way, but we have logs. Everyone's familiar with these. We have structured logs. And if you want to look at it in a certain way, logs are key value pairs. They're arbitrarily wide. As many keys as you want and as many values as you want for those keys. You have metrics, which are going to be a log with the aggregate, so the value that you're attaching to those, whether that's a count or maybe it is something like a heat map. And with those, like we said before, we can't do high cardinality fields, at least not with traditional Prometheus. Then we have traces, and traces are really built of a graph of spans. And those spans then also are logs. They are key value pairs with high cardinality wideness, but also they are guaranteed to have a start time and a duration. So if we get down to tracing just a little bit more, and I know there's a talk on tracing by J.J. Phillips a little bit later today, so you should go see that as well. But we're really talking about connected spans in a causal tree. So metrics don't give us causal reasons for what's happening, but our traces do. So we have high cardinality custom fields that we want to match our log attributes for ourselves at least. And for us, that really means that when we have our log attributes, maybe you add, let's say that you have bill pay and different providers. You're adding those onto those. We add it to the logs as well as onto our traces. Logs and traces are just events. And with those then, you can kind of get down to your logic, your business logic, or your reasons. And what we're really tracing or spanning is our network boundaries. So the easiest way to start is maybe you're talking to Redis, you trace there. Maybe you have a service, you trace that. You have a Postgres call, you trace that. And for ourselves, it's all hand instrumented. So what that really means is we're not using a OTel APM. Inside of our applications, we start a tracer up, and we span at each event that we think we need to. So for an example here, we have a service request at the very top, which is going to be what is our Node API gateway. So we just have a gateway that's built in Node. And service comes in, and it takes 269.1 milliseconds in total. You can see that on the very right-hand side. There's also the span kind as a column. And what you can see then is it has a child named middlewares, where you can see that took 0.18 milliseconds. And there's another child below that that started right after middlewares was done, and that's auth and enrichment. So that's all our auth n and auth z. There's 30 different spans under that. We just collapse them down into one. But what we can see is we can kind of tell a story of what happened to this user's request. That's not something we can do with metrics. So this will be a video. I'll just talk right over it, but a little bit more in live action. So the trace is a trace ID, normal UUID that you probably use like XRequest ID. And every single field on this specific span, the server span, we can kind of look at. So here we're going to look at /accounts. We can see that it's there. We can see every single field. So we have our user ID, our usernames tagged, our primary logins, our headers. Every single little piece of data that we can think about tagging, we should tag. It's free. So, and then you can kind of see once again, the causal relationships. We have all of our auth and enrichment that happens immediately. We have the resolvers. And eventually we get down to the proxy request. So once all of our auth n and auth z is done, we can ship back all the way down to our service. In this case, it's the accounts API. And the accounts API then has a client call out. So once again, we're spanning networks. And we can kind of add columns here. So we add the route to kind of show that. But what we're really getting at is that we can see exactly what happened to the user's request all the way down. And this is through 20 or 30 different microservices. Yes, you can see this with logs, but you're depending on the times on your servers. So how we got to that specific request then is going to be how you query in Honeycomb. And that's going to really come down to what are you looking for? What's the exploration that you're doing? So for here, we have count and P99s and heat maps as our visualizations. We're looking at only server spans within Node API Gateway, and we're grouping by HTTP status code. So you can see that the graph changes as we kind of mouse over those. But what if we want to look for something a little bit different? What if we want to say, hey, I want to look at only /accounts routes? So on the fly, we can build this, right? This isn't a dashboard. This is an exploration of the system at the time. So as I fuddled through this when I did this, we'll run the query. And now the graph changes, right? We're only looking at /accounts. But what if it's per institution? We have thousands. Well, we look at each of the institutions, and well, those graphs look very different. So what if we want to look at a very specific institution, because that one looks interesting, and we need to dive in a little bit further. So then next, we can split it by user ID. And going through this exploration is very different than dashboards. Dashboards, you need to know what you're looking at. Onboarding new people is very difficult. This, they just need to understand the tool and how things are tagged. So I mentioned OpenTelemetry. It is essentially an open source protocol for tracing, metrics, and logs. And the best way to probably look at it is that it's write once and send anywhere. So you send this protocol, you can send it to Datadog if you would like, you can send it to Honeycomb, you can send it to any provider, but what we do is we actually send it to an OTel collector. And there's a cluster of OTel collectors that have receivers, as you can kind of see on the left-hand side of that image. So it takes an OTLP. It might take in Jaeger if you're using that protocol still. It takes in Prometheus. And then you run processors. So our processors add our K8s attributes to them, for example. They might search for credit card data in tag fields and then remove those. They're all custom. You can write whatever you'd like. And then you have exporters, which means that you're writing this once here, but you can export anywhere you want. So we could export to Honeycomb. We can export to Honeycomb and Datadog. We can export to Honeycomb, Datadog, and Prometheus. But we actually end up going to Refinery, which we'll get to in a second. So Refinery is a tail sampling mechanism. But first, we should probably define sampling. So there's head sampling, which at the time of the request, you decide whether or not you want to keep it. So you might do it based off some logic. You might say all payments requests. At the top level, I'm going to set this header, and it's going to pass all the way through. Or we do tail-based sampling, where it collects the entire trace, and based on a rule set that you provide, it will decide to keep it or not. And for ourselves, our dev and staging keep everything. So all of our engineers have every single piece they need. For prod, we keep all errors. If a user's having an issue, we can see it. For everything else, we use something called EMA Dynamic, which is essentially a sampler that says, based off the keys you told me to look at, this looks interesting. I'll keep it. And lastly, we've already shown Honeycomb a little bit, but the reason the tooling was chosen there is it's explorative. I'm allergic to dashboards personally, and I don't think that they're a great way to onboard new people nor solve problems that are actually new problems. If you're not fixing your old problems, dashboards are great. So another query in Honeycomb, we have a heat map of the duration of all server spans that are 200s from /accounts. So these are just good calls. And bottom is a heat map. We can highlight, so that yellow part is a highlight over everything that's above 100 milliseconds. So we're kind of asking the question, what's different about these things that are slower? And what's shown then is there's a little graph on the bottom that compares all the attributes statistically and says, hey, these are different. And for this, it was 2 institutions that were slower. It's not specifically maybe a pod or something else. Doing this through a dashboard when you have 1,000+ users or 1,000+ institutions is pretty difficult. So challenges, which there will be one on each of these sections of kind of hardships that we've had with these, is your training on tools is hard. I'm sure everyone's moved logging providers before. As you kind of do this, it's not an easy concept for people to grab. You have to train your support staff, you train your engineering, you have to train your managers. The issue with moving to tracing is that you now have to treat a new tool, but also a brand new way of thinking and a brand new type of telemetry. You're moving away from what people really know, and probably the hardest part of all of this is the instrumentation of your services ends up taking quite a bit of time, especially if you're working backwards like we were. We took 9 months to instrument all of our services. But going forward, all of our services that were built were auto-instrumented with our frameworks. And the other issue is that you want contextual information to your services. If you have a bill pay system, you want bill pay attributes on each thing that's there. Just the clients and HTTP status codes aren't enough. And lastly, as I've kind of alluded to, sampling's really hard to get used to. Engineers expect that their logs are just there. And it's not financially viable to do so. So making sure you're sampling the right things, and it's a continuous process, is kind of how you need to go through it. So here's a quote from the observability engineering book that I find to be maybe the most apt way to describe observability now. But observability for software systems is a measurement of how well you can understand and explain any state your system can get into, no matter how novel or bizarre. And really that comes down to, yet again, if you tag all data you have, you don't need to care about what you're going to do with it. Just tag it because you know it's there. You can go and look through that data later. You don't need to rebuild systems to go do so. So we can at least have data now. But what are we measuring is kind of the next question. And really we need to measure what matters. And really when we talk about what matters, we're talking about what matters to our users. So what matters to our users is uptime usually. Might be described in time or number of requests in percentages. But we're going to translate that to an SLI. So service level indicators are performance measuring as predicates. So we're going to get Bool values out of these. And a couple examples then, just really easy ones, are like we had a request to accounts before. We're going to say that all of our requests are 200s or they're failures. It's a pretty easy one. That's just an error-based SLI. Or we have all requests are faster than 200 milliseconds. And that's a latency SLI. Or you can combine both. You could say that all requests need to be /accounts, 200s, and less than 200 milliseconds. Or you could say that just this service needs to return within 200 milliseconds. It's going to be very contextual to your services and how you define it. So we can define up as a Boolean. So now we need to really define like what amount of time is up. What's good enough for your customers? How many times do you need to use an app and have it break before you uninstall? Is that happening to your app? So what percentage of requests can we fail before our users lose our trust? And that's, once again, going to be contextual to your application. Examples, yet again, are like 99.9% of requests to /accounts will be HTTP status code 200s over 30 days. You might change it to 7 days. Or you might change the throttle down to 99.5. And all of that depends on what guarantees you can provide, maybe based on your infrastructure, based on your code, or based on just what the users require. Maybe 99.9 is not the requirement that you actually need to hit. Maybe it's 95. Maybe it's a system that actually has a failure mode to give you an image that's not their image, but it's fine. Some things aren't worth fixing. And Charity has a very, very good quote on this, but nines don't matter if your users aren't happy. Measure the right thing. So this is an SLO inside of Honeycomb that we can kind of walk through a little bit, and we'll also get the actual website in a second. But we have an SLI, yet again, of 200s, and durations are less than 60 milliseconds. This is actually our internal accounts API. So this is the one that everyone else uses to get accounts internally at Jack Henry. Our SLO on this is 99% over 7 days. So with that then, the right-hand side shows SLO compliance. That's pretty self-explanatory. You see where you are at the time of the day. The left-hand side is something we haven't talked about, and that's budget burn down. So you have a certain amount of times you can fail before you slip below 99%. And how your teams and how your managers and really your company deals with getting close to that number or going below it is going to change how you're going to react to these. If you immediately get close to this number, let's say that you're at the point right now, maybe you need to start making a fix. Maybe you can't do risky deploys because you're going to get sued. Below this is yet again another heat map, but it's color-coded to where the failures are in yellow and the successful requests are in the light green. And what it does is it then runs the bubble up for you and tries to tell you what's actually failing in your services. In this one, you can kind of see that it might be a specific URL on the bottom, but one thing to kind of look at here is there's 85 tags just on this single service. So we can go and compare and look at all of them. So this one is our discovery as a team of ours, and it's the accounts API. So it's one less than our Node API gateway, so it's right below it. And it's the /accounts, so this is one of our real ones from prod. We have 99% SLO on it. We're looking at /accounts. This is an SLI written. Looking at the accounts API, get methods. It's a server that we're looking at specifically. You want less than 300 milliseconds, and we're setting 200. So this is an error and latency SLO together. The top right has an alert for when budget burn down is going to hit 0% within 4 hours. And you can see on the left-hand side that the budget burn down's at 87.1. And if you look on Friday, we had some blip on Friday. So we pretty much burned down 13% of our budget for the day, or for the actual time period. If you look on here, you can see those same failures on July 19th. You can see where they're all at. And below that then, you'll see the bubble up that'll help us try to figure out what was wrong. Well, it's header string of 0 size, so that's good. But if we really look, it's a single user. This is not uncommon for us, but we don't see this in metrics. In metrics, we just saw that we were failing all day. And in reality, it's a single user. We can go then dive in to their specific request that we have recorded and go look at what they were doing. But this just made a 3-hour adventure for some engineers 5. Just 5 minutes, and they can get there. So there are still many challenges in SLOs. We still have not fully rolled out ours, honestly. And finding SLOs for each feature and getting the right people in the room to describe those and define them and agree on them is quite difficult. Your profile photos might not be that important. Maybe they don't even need an SLO. But what about getting accounts? What about money movement? And once again with that then, starting to use SLO budgeting is a bit more difficult because your users and engineers are really, really used to percentage-based failure. I don't want to give up my alerts. I've written them, and they work really well. They wake us up when we need. Well, that's good. Can we try to move towards when users are seeing pain? That's when you get woken up. The intent here is not to have double alerts. They should probably both fire if they're going to fire. But you can have percentage-based failure that does not cause user pain. If you're super far below and there's a failure mode on top of you, maybe someone reaches into a cache and that's acceptable for the product, you don't need to get woken up at 3 a.m. And lastly, and this is a consistent thing throughout this entire talk, is we're talking about systems and not services. So teams become very service-oriented. This is my service. But in reality, as we saw with just getting an account, it hits 40 of our services. None of those probably owned by the same team. Who gets woken up? That becomes a cultural issue. Which kind of brings us down to system design and really taming complexity that we've accidentally built or purposely built. So I had to include a Dijkstra quote. So simplicity is a great virtue, but it requires hard work to achieve it and education to appreciate it. To make matters worse, complexity sells better. I'm an engineer who loves shiny, new, sharp toys. I'm sure many of you are as well. We gravitate towards them. And it turns out they're quite complex. So simplicity is a hard one to talk about, right? What's simple to me might not be simple to you. But there are ways to kind of measure complexity in your systems. And maybe that's just how long your training takes. Maybe it's how many different ways you're going to do something. How many different config ways do you have to do something? Do you have poor or missing documentation? I know we do. What about diversity of deploying things? And then one thing that's supposed to considerably increase your reliability is retries, right? Well, that adds complexity. Have you ever had a retry storm? It's not a great time. So systems are going to increase until we actually try to take down complexity. Someone needs to champion this at your company, whether it's you or someone in leadership. It's only going to increase as you build more products, as you change things on top. Things can be really quite simple too. So fetching data once and forwarding is a great example for ours. We had everyone grabbing a user all the way down the chain. There were 18 calls to the user service. Instead, put it in the header and send it along. It saved us a bunch of pain. And it even could get down to like the code depths. So we run Scala, binary compatibility, and that is an interesting time. And anytime you have dependencies that aren't used, why are you making people actually think about them? Just go clean it up. So for us, though, like when we're going to roll out features, we have a new feature we want to get out. What do we kind of need people to do to kind of reduce complexity, to actually give them essentially free gains? And that's logging, metrics, and tracing. Like those come immediately from our framework. And feature flag rollouts. Deploying software into Kubernetes, a new version should not be when you deploy a new piece of the application. Changing a flag should be that thing. You can separate, hey, this is a fresh JVM, from, hey, we just changed the flag and now it's doing something different. Internal and external API docs are required. Lack of API docs causes so much confusion. Then also on-call runbooks. Like if people don't know how to actually get through your services, and at 3 in the morning, if I have to figure out what this graph means, I'm not going to do it well. But then we get to the reliability framework. So what we have is each of our languages generally provide a more drop-in experience. So I don't need you to understand how to build a tracer in OTel. I don't need you to understand how to take the jot that we have, tag all of it onto your traces automatically, tag it onto your logs, and make sure it doesn't die. That should not be an issue. I don't need you to think about timeouts that are defaults based off of what the API has. And I also don't need you to think about a health server. We run in Kubernetes, but like, if everyone is having to remember how to compose your apps every single time, it's a waste of time. So really, we kind of go through an exercise. What happens if dependency X slows down? This is a common experience for us as we are multi-tenant, and the cores are single-tenant. So as one core goes down or slows down to 60 seconds, let's say, what are we going to do about it? How does the service react? Or what's the correct timeout? What's the correct timeout to ensure our services are alive? And what's the correct timeout to ensure an actual good user experience? Those might be different. And if you're overloaded, what are you going to do? Do you fail fast? Do you try to queue requests in the background so that you can get them completed? Are they payments? Do those matter more? Can you fail payments? And like, what are we circuit breaking on? Are you circuit breaking on your own services? Are you doing it only on things that are bulkheaded? And once again, how does one financial institution not affect another? We have institutions that are 300,000 users, and we have institutions that are 20,000 users. How do you make sure the 300,000 user institution does not kill off the 20,000 when it goes down? Which kind of gets us into things are going to go wrong. We're going to have incidents. And really, all this is about is how are we going to respond in a structured way so that people don't need to think about this? For us, we use the automated bot, which is Jelly. They're a product that is now owned by PagerDuty. But it's really just there to wrangle people, get communication started, and send out updates. And for us, we really believe that anyone should be able to start an incident. Support, junior engineer, person started yesterday. All of them should be able to start an incident and say, hey, something looks weird. So we need to provide that value and provide it automated for them. So like we said, what does the bot do? Starts in a Hangout. Great. Invites the relevant service teams based off PagerDuty. Great. We broadcast to a channel that says we're having an incident. That's all that channel's for. We then assign an incident coordinator. So if you were to do a /jelly open today inside of our Slack, this is what you come to. You get a summary that you want to say, like, something looks weird. You automatically filled out with investigating, your severity level's already filled out, and it automatically shows you where it's going to go post these updates. As you can see on the right, channel gets started. It doesn't have to be private. This one just happened to be. It gives helpful links. So we have a domain ownership sheet because we have way too many domains. We have a link to PagerDuty, a link to Honeycomb. You might have your link to your runbooks there. And then it adds all of our leadership that needs to be added, as well as the service teams involved. Let's say you're halfway through the incident, and you need to post an update. Jelly's going to ping you every, I think it's 5 to 15 minutes, it's up to you. And it's going to say, hey, we haven't given an update lately. So the thing that we all forget to do during an incident as we go heads down is really part of the incident commander's job. But as this helps you, you can do a status update. You write the status update, it gets posted in the thread in that broadcast channel. No longer do you have to remember to go post it in a different channel or remember to ping John because John needs to know. Like, he can just go look here. People that aren't involved in the incident can look here. They don't have to join the meet. So I mentioned incident coordinator or commander a couple of times, but really, they're there to facilitate. They're air traffic control for your incidents. And their responsibilities are just coordinating changes and releases. If infra and engineering wants to change things at the same time, don't let them. That's a terrible choice. One at a time. See what happens. Use science. So communication to stakeholders is another one, once again, done through the status. And it's really to keep things moving forward. But with that, anyone is this role. It doesn't have to be engineers at your company. It doesn't have to be EMs. Anyone that wants to learn how to kind of control traffic during these incidents can. So there's, of course, always challenges. And the biggest challenge here is this involves all of your staff, it seems like, right? Everyone needs to be involved. Everyone needs to know the process, because if our mean time to resolution is 20 minutes, we're probably dead in the water. And training incident coordinators is something we've not gotten right still. Atlassian has a great write-up on it. But finding the right way to train people under pressure and with the amount of noise that might happen with really good engineers who are intentionally good but are causing havoc is hard. Figuring out who should be involved is hard. I don't know if you've all been in the incidents where it's 45 people and you're like, what is everyone doing? But it turns out, like, how many communications people do you need? Can you cut that down? Can you make it easier for them to get the right communications feeds? And lastly, it's practice. And the best way to practice is to have incidents, which is probably not what a lot of people here want to hear. So we had our incident. At least that's done. Now we have analysis. Postmortems and analysis are really there to drive organizational change. We want to teach our engineers and our EMs and anyone that we work with how our systems work, and especially how they fail. What you want to do is you want to write a story. You don't want to bog it down with unnecessary details, but you do want to get people involved that weren't involved. You want to help them understand why this was an incident. And it requires follow-up meetings. Writing the incident analysis and throwing it in GitHub, for us it's in Jelly, but like if you throw it in GitHub and no one reads it, that's pretty useless. So they're learning tools. You need to actually work upon them. Learn from incidents. LFI is an entire website you can go to and look at incidents that people have had. And going through those is a training exercise. And cross-team reviews. I don't know, our team size is around like 6 to 7, 8. And one team having an issue out of our 10 for Scala doesn't mean that the other ones didn't have it. They might just not have written up something, or they're not talking about it, or it didn't affect their SLO enough to actually look like an issue. So doing cross-team reviews also gets them to say, hey, this is a problem in our system too. So an example of an incident template, you have a problem summary. For us, that is very specifically going to be for our customers as well. And then you have graphs and data. You want to make sure that you put every piece in there that someone made a hypothesis from. You do a detailed timeline. So with us, with Jelly especially, that is going to come from, as you'll see in a second, come from Slack. And we do a root causes and triggers. So a 5 whys is like, hey, why did the alert go off? Well, the alert went off because it was slower than 400 milliseconds. Well, why was it slower than 400 milliseconds? Well, this dependency slowed down. Well, why did the dependency slow down? It's a very easy way to get people talking in your org. So then there's a section for impact. Whether it's internal or external users, both are going to matter, but maybe this was just an internal issue. Maybe all batching went down for a bit, and users aren't going to see an issue, but we need to talk about that. There's action items. Those need priority, and assignees. Those also need to go directly back into how you do work. They cannot be a side issue. Lastly, an incident owner, someone that's going to make sure those priorities do get done and get talked about. And then a lessons learned section. Like, what did we learn about the system? Maybe we learned about a new library issue. So this is Jelly's demo account. We're going to click on to one of the opportunities, which is actually just an incident. And as you can see, there's the overview. We have it when it started, when it ended, when it was last imported. We have the incident coordinator and investigator automatically assigned, and then the summary that we talked about. They have a narrative piece here, but what we're going to look at is like how we can pull from a Slack channel that we were in, and we can pull that directly into what we build as the narrative. So we can click on Jen Harvey. We can say, hey, this was a detection. We can write something there about what was happening, and it gets added to this narrative. And what that allows us to do then is we don't have to go and remember what happened in the Google Meet. If we put everything in writing as much as possible, we're able to use this tool to kind of go and do that. It also is a way to look at who was involved, where they're from. Maybe you're interrupting someone's dinner consistently. Takeaways, action items, all that stuff is there. The bigger thing for this is, as you'll see, we're going to be able to export that report. And first thing, we have a summary that we want to send to all customers. Great. Sport's taken care of. So now, what if we want to just do something for execs? We need a narrative and summary. We can do that one as well. And all these just get exported to PDFs. So this really kind of makes it a lot easier and faster for how we're doing this. Of course, there's challenges. If you don't do this already, this is going to take a lot of time. Filling out analysis and understanding systems is hard. The other issue, though, is that if you're not understanding your systems, you already have a problem. When do you do a full analysis? If it's a blip, do you actually do a full analysis? The answer is probably no, but you have to find that line. And these need to affect priority. If something needs to be fixed because it's hitting SLOs, it needs to get into the priority. If it's not, there's probably going to be a bit of an impedance mismatch between engineering and your system. And lastly, like, these are system level issues. This isn't one team. So if your teams are very insular and they are like, hey, this is our services issue, it's not. Their fix might actually affect another change onto another system. So we've been here. And really, once again, it's kind of just all these pillars kind of build on each other. But if you have tracing, you can really dive in from the large down to the small. You have exploration. Measurement based on SLOs has affected us by quite a bit by making it much easier to talk about how customers are impacted rather than just services or teams. Your complexity is going to grow until you stop it. You need to remove your hurdles for incidents. And analysis for all these is the root cause, but it's learning. It's getting people to understand and talk. And really, it's just staying curious about systems. That's it. Are there any questions? Yeah.
Can you describe your auto instrumentation like the out-of-the-box stuff?
Yeah. The question was if I can describe the auto instrumentation that we do. So, are you talking about the framework that we that we've built, or just OTel?
You mentioned that people don't have to think about it.
Yeah. Okay. So we run a bunch of microservices. I'll just talk about our Scala app specifically. One second, my throat's dying. And we have it so that we, when a service request comes in, we pull all of our JOT information out of that service request, and we tag that into loggers and tracers already inside of the framework. It's just a library. And what you can do is you insert your HTTP server into that. So HTTP server for us is just a type in Scala. And you insert that in, and you say, hey, here's my HTTP server. It doesn't matter what it does, but it's going to take that and extract that JOT, tag every single log and trace, which is specific to that specific request, automatically for you. So when you use the logger, it'll automatically have all the information about the user. You don't need to think about doing it. And it also auto-traces your server. So it'll start the span immediately for you and says, hey, here's the span. I've created it. It has all the information about the user. You tag what's interesting about your service. Maybe you have a bill pay service or a transfer service. So really, it's just about writing the glue code on top of what already exists and then making sure it's easy to plop a new server in. Does that kind of help you? Yeah.
Are you guys leveraging that, or do you guys have little snippet code in every service that like kind of is a custom piece of you guys that's shared with other applications?
Yeah, the question was whether we use the auto instrumentation that gets injected versus essentially manual instrumentation, and it's all manual instrumentation for us. We found that to be a lot easier for getting exactly what we need. We're also in a weird language, we're in Scala, and we're also in pure FP Scala. So we get into like playing the weird coins pretty fast. So we've also written our own library, et cetera. Yeah.
Question about the incident analysis. How do you manage incident analysis across functions? Do you get other functions controlling your PIRs? And do you have any tips on how to maybe streamline the PIRs, PIR meetings, considering how much maybe it's involved to analyze the incident across a function?
So if I heard you right, how do we manage cross-functional? Okay, so cross-functional incident analysis. I guess I come from the viewpoint that this feels very easy of just like you pull all the teams in. I know that's going to disrupt a ton of stuff, especially if you are not used to this. But getting the most junior people involved as well as the people that are most senior is such a great learning opportunity that I think it pays off in dividends. It's also helping each other like understand what's going on. So our Node API Gateway team, understanding how the account service works better so that they can think about what failure modes they might have on top of calling it is a really, really good idea. But maybe that doesn't happen without an incident and without really talking it through. Maybe that's not what we did because it's been done for 10 years. Does that kind of answer your question? I'm happy to talk afterwards too.
You mentioned a bit about just challenges and adoption and getting this. What was it like for you all? Was it that a pocket of teams had this already? Was it you were having trouble responding to incidents and this solution? What was kind of your success at?
That's a good question. So the question was, what was our path essentially to getting here and what we had before? We had a sort of incident analysis and process before. If we're being really honest, it was not followed more than 5% of the time. And I think that's for a couple of reasons. I don't think people got the value out of it. I don't think we took a learning bent to it, if I'm being honest. It was a check mark. And if you treat things as a check mark, people are not going to get value out of them. They're going to get the check mark done, and they're going to be completely done with it. I think having someone lead them as well. Scott Merrill's in the room with us right now, and like he's led a lot of ours, and it has brought dividends across everything because it's not someone who does. I think it's more that people are nervous to do it, or to put blame on something. And having someone else facilitate and kind of be like, hey, what happened? I don't know. I have zero ideas of what's going on, but like let's talk it out. Let's just like figure out what's really happening. I think if you approach it that way with learning and from an aspect of wanting to get better as a team rather than a very blameful version of it, or yeah, I think really the LFI aspect of it is probably what I would really shift towards. And I think that's what's shifting for us. And honestly, we're not fully there. We still have incidents that don't have analysis done. And I think that's more of a time-based thing too, where people feel like it's crunching against other things. Yeah.
What's the process that you follow if you see it starting to slip where people are, not sticking to the process?
For incident analysis or for like SLOs?
For incident analysis.
For us right now, it's been polite begging. But I really think it's a process change, right? So there's a socio-technical issue here of just like your engineers feel like they are supposed to write code most likely. Okay. But what if we helped the write the code be the thing that actually improves our SLOs? So I think you need to tie it back to like, what are you measuring? And for us, like, if we're really honest, in the last year, like, I don't know if we were measuring the right things. We were measuring services. And that was an idea of healthy. but it was not the health of the user. And I think trying to push that story helps quite a bit more. I think you're going to get a lot more people with a carrot than a stick on this one as well.
You mentioned having an open API as well as internal usage. What sort of behavioral differences and what challenges do you encounter?
Yeah, so the question was, what kind of behavioral changes and challenges do we have with having an open API versus just having our own user base through our applications? And the answer, I think, is really like, without that, I do not think we would have, so without having tracing the way we have it today in our observability stack, we would not be able to separate those two very easily. And I think we would have a lot of more problems, if I'm being honest. To kind of get into that a little bit more, like the patterns and traffic patterns that happen from, for example, Plaid or Stripe are going to be a lot different than what our applications do. Our applications have an exact endpoint list that they hit in an order, and I can tell you where it died. I have no clue what Stripe is doing. So I need to be able to dive into Stripe. Then I need to be able to dive into which machine Stripe's using. OK, well, these machines are acting differently than these machines. Well, how do I split that? Well, this is exactly where Honeycomb comes in. You keep grouping by. You filter. I think that's kind of the answer to that. Is I think you need observability when you start having different traffic patterns of users.
As you sort of try and focus your alerting on user behaviors and systems as opposed to services, I think you call this out as a challenge in terms of who to page, who to get involved. What have you done to try and address that challenge?
The question was what we've done to address the challenge of who to page. I still think this, honestly, is a thing that we're working on. I think it's really easy if you can draw boxes or more boxes around features instead of services. And this is where we've kind of failed originally as we were building microservice architecture, is everything was like, oh, well, this is this service. Well, that's cool. It's used with the other 14 services that make up bill pay. So who gets paged when Banno users dies, where we can't get users, but we're during bill pay? And currently today is both. Because if Banno users is dead, someone on the Banno team needs to actually deal with that. If bill pay is dead, they also need to be aware because their SLO is about to burn down, and they're going to have to talk to someone. So I think it's both right now, and I don't think that's also the best answer. I think that could lead to burnout, honestly, on teams that are like the users team or the accounts teams. Alrighty, well, thank you all for coming. Please visit everyone out in the foyer. Thank you to the sponsors. You've all been great. Thank you.